Okay, let's look at this question. Graphical inequality 2. We have said something about a graphical inequality 1 when we discuss on when to make use of a dot line and when to make use of a solid line. And in that case, we say that we can make use of a dashed line when we have less than or when the inequality is greater than, but we make use of a solid line when the inequality is less than or equal to, or when the inequality is greater than or equal to. So let's look at this question. It says, on the same grip, draw the region defined by the following inequality by shading the unwanted region. The first one says 3y plus 4s less than or equal to 24. Less than or equal to 24. So in that case, we have this to be 3y plus 4x less than or equal to 24. So this less than or equal to, I will change it to equality sign. We have 3y plus 4x is equal to 24. So making a table so that I can be able to draw it on a graph, we have here to be x, here is y. So when x is 0, when we place here to be 0, y will be 24 divided by 3. So y will be 8. So when my y is 0, if I have here to be 0, x will be 24. If I have my y to be 0, x will be 24 divided by 4, and that gives us 6. So the 2 points we are having now is when x is 0, y is 8 at this point, and when y is 0, x is 6 at this point. So we have a straight line joining the 2 points, the 2.8 and there and 6. So since we have here to be less than or equal to, we are going to have a solid line. If it is less than, we have a broken line. So since it's less than or equal to, have a solid line. So where are we going to shade? We said 3y plus 4s is less than or equal to 24. All these places are less than or equal to 24. So all these places are greater than. We shade the unwanted part, the one that is greater than 24. So I will shade this part that are greater than 24, because what we need are the part that are less than 24. Okay, then we go over to the other one. The second one says y is greater than x minus 3. Y is greater than x minus 3. Y is greater than x minus 3. So in this case, if I have this to be y equal to x minus 3, we have the table. When this is x, this is y. When x is 0, y will be minus 3. And when y is 0, x will be 3 if I substitute here. So we have the point when x is 0, y is minus 3. So minus 3 will be at this point down. And when y is 0, s is 3. So 3 will be at this point here. And now we have a straight line joining two of them. We have a straight line joining two of them. Now look, we have that to be less greater than, so the line we are supposed to have will be a broken line and not a solid line. So we have a broken line and not a solid line. Okay, so in that case, where are we going to shade? It says y is greater than s minus 3. Y greater than s minus 3. Now all these places are all okay. Before we can find that, we have to check 2 points. Here we have y to be equal to x to be greater than x minus 3. If I take 2 points, maybe I would consider this 2 points to see if I'm going to shade here or I'm going to shade under. If I have these 2 points, 2 and 2, x2, y2, you can take any point there. If I have the 2 points, x2, y2, that means x is 2, y is 2. If I substitute here, my y is 2 greater than here, s is 2 minus 3. That means 2 is greater than minus 1. This is correct. 2 greater than minus 1 is correct. Okay, let's check the other one. Maybe I check another point here. If I have here to be, maybe I'm taking another point 7 and 2. The point under 7 and 2 here is 2, y is 2, y x is 7. Y is 2, y x is 7, y is 2. We have x and y. Okay, if I replace it here, 7, my y is 7, my x is 7, y is 2. We have 2 greater than 7 minus 3. Now 7 minus 3 is 4. Is 2 greater than 4? No. So it is wrong, and we are going to shade the wrong part. So we are shading these parts that are wrong. We don't want this part. The unwanted part is what we are shading. Okay, now the last one there is x greater than or equal to 2. X greater than or equal to 2. In that case, x greater than or equal to 2, I'm going to have, first of all, check x equal to 2. If I take x equal to 2, at which point is x equal to 2? I can find out that my x is here, which is equal to 2. I'll draw a straight line here. If I draw a straight line here, x equal to 2. Okay, sorry. X equal to 2. Now at this point, since we have this to be that x is greater than or equal to, so we are going to have a solid line. Now I'm greater than or equal to 2. All this part here, all these points here are greater than or equal to 2, while all these points here are less than. So we are going to shade the unwanted part, the one that are less than. So all this one are less than the unwanted part. So you can see that we now have a small triangle there, which we call the region. So this is the region. Now the next question that follows says, are these points on the region defined by all three inequality? The points are, the first point is 1 and 1, 1 and 1, x1, y1. Let's check. My x1 is here, y1 is here. You can see it is outside the region. It is totally outside the region. So this first one is no, because it is totally outside the region. Then the next one is 2 and 2. X is 2, y is 2. X is 2, y is 2 is on the line. You see, it is on the line. So since that this line is a solid line, and solid line means that it is inside the region, it is greater than or equal. So it is included, is inside the region. That means that at that point, this point also is included. Then the number 3, third one means 3, 3. X is 3, this is x3, y is 3, this is y3. Because the point is here, that means it's directly inside the region. So this one also is yes. And the last one, 4, 4, you can see that here x is 4, y is 4, y is 4. So you see the point falls outside the region, so outside the region. So in this case also, here is no, because the point falls outside the region. So this is how we solve the inequality.